Dr. Lowndes, we met a year ago for the first time, and we had an interview, and here we are a year later at the National Health Association Conference again.
Right.
And it's a pleasure seeing you again.
It's great to be back.
Yeah. Might as well jump right into it. The Warburg Effect. What is glycolysis and all these things, glutamine and all that?
Yeah, so the Warburg Effect has really been a hot topic lately. There's a lot of citations on his original work back in the 20s. And he was a brilliant biochemist who discovered, way back in the early 1900s, that cancer cells have this ability to produce lactic acid orders of magnitude greater than their surrounding cells. And so that really caught his attention, and he kind of drilled down and found that what these cancer cells were doing was relying on a primitive form of energy called fermentation. And so to understand that process, you really have to have a little bit of biochemistry. I apologize, this may bore some people, but it's important that you realize that under normal conditions, fuel in the form of glucose in humans typically is metabolized through a process known as glycolysis. And if you've had some basic biochemistry, you realize that glucose is a 6-carbon chain, and it is split into 2 3-carbon chains through the process known as glycolysis. And that lets off a little bit of energy. To really get your bang for the buck, you need to send this pyruvate, these 3-carbon chains, through a system known as the Krebs cycle, which is, if you've seen any sort of metabolic pathway chart, it's the big circle in the middle. And this pathway, under normal conditions, runs in what we would call a forward direction, and it's generating products. It's breaking down that glucose molecule and taking carbons away, putting some more on, et cetera, et cetera. And the whole idea is to produce a molecule known as NADH. And this NADH, in turn, spins off and falls down what's called oxidative phosphorylation. And in doing so, down that cascade, it produces an enormous amount of energy in the form of ATP. And so that is where most of us get our energy. If we're called on to run a sprint or climb a flight of stairs, we need that ATP for that burst of energy. Mm-hmm. So what Warburg noticed in his early studies is that that's not what's happening in cancer cells. In fact, the Krebs cycle and oxidative phosphorylation is bypassed completely, and that pyruvate instead goes on to ferment into a product called lactic acid. And we're somewhat familiar with lactic acid. That's what generally pools in your muscle after you've run a long race and you're sore, and it takes a few days to wash out, and it's generally thought of as a waste product. And so it's very curious that cancer cells would avoid this energy-rich pathway and instead opt for a fermentation pathway, which only makes just a handful of ATP molecules compared to the more conventional method. And so that, in a sense, is the Warburg effect. And Dr. Warburg was quite an energetic, very opinionated guy, and he was determined or convinced mitochondrial damage was the crux of the issue, that these cells were incapable of performing oxidative phosphorylation, and therefore they had no choice. They went down this fermentation pathway in somewhat of a de-evolutionary process. In other words, de-evolving to a lesser life form. Mm-hmm. Things like yeasts, for instance, considered lower life forms, heavily dependent on fermentation processes. So that was Dr. Warburg's observation. That's not what he won a Nobel Prize for. He won a Nobel Prize for discovering a molecule involved in oxidative phosphorylation. But today, that's what he seems to be known mostly for, is this Warburg effect.
Now we have many decades later, a lot of hype around this. What's that all about?
Right, yeah, so it's really taken off. If you Google the Warburg effect, you'll see that citations have really hit the roof. And there's a resurgence in this idea that respiratory damage, or more specifically mitochondrial damage, may be the crux of what's driving this cancer growth. That all might be well and good, but it's far from universal. There are many cancer cells that have perfectly viable mitochondria. They're capable of oxidative phosphorylation. However, in the presence of oxygen, they still ferment. So there's something else going on here. And it appears to be what we would call biochemical flux. In other words, fuel is coming through these pathways, and at each point, there is a decision to be made. Should we go down this pathway to make high energy reserves, or should we go down this other pathway to promote growth? What we've been noticing or determining lately is that the glucose is entering this Krebs cycle, and the Krebs cycle is actually traveling in reverse now. And what it's doing is spinning off substrate. Because if you think about it, a cancer cell needs more than just energy. It needs materials. It needs raw materials. It needs to make more RNA, more DNA, more proteins, more lipids to make membranes and such. Where's it getting all that? What we're finding is that the Krebs cycle actually runs in reverse and starts throwing off substrate that's now made available for the cell to reproduce and move forward. So the crux of the issue seems to be, what is controlling that flux? What is causing the cell to either go towards an energetic route or go into a state of growth? And there's some, it's a very promising research on the horizon, but so far it's still eluding us. Yeah.
When you talk about respiration, it's either anaerobic respiration or aerobic respiration. Well, how might I be affecting this? Like, is it that I'm not exercising enough and getting enough oxygen in, or is it out of my control? On the cellular level, is this something that's within my control, how that respiration occurs?
So the bottom line is, take care of your mitochondria. Take care of your respiratory cycle. And you do that by stressing that cycle and demanding more energy of it. And that's going to help shunt the flux in a favorable direction and away from growth. Exercise is a scary word for a lot of people. Everybody thinks they've got to hurt and they've got to sweat a lot. Really what you need to do is move and really make demands on your systems. Take the stairs instead of the elevator, those sort of things. Park as far away from your office or the store or wherever you're heading as possible. Keep moving. Keep lifting things and moving around, doing normal activities.
Stand instead of sit.
Stand instead of sit. These are all very simple ways to take care of your mitochondria, because the respiration seems to be so key. But keep in mind that, cells are not constantly in this state of ATP production. I mean, we're sitting here, we're at rest. There's really no need for me to be accumulating a bunch of ATP because I'm not going to be using it. And so the cells have checks and balances. And so when ATP starts to rise, that pathway now shuts down and things go different direction into a state of growth. So if you think of yourself, say, as an athlete would, they're going to be working out hard, working hard. They're going to be making demands of their oxidative phosphorylation pathway, needing that ATP to move forward. And then they got to rest. And so when we rest, that ATP builds up because we're not using it, right? And then the Krebs cycle naturally goes into reverse to make substrate to repair the damage from that exercise. In cancer, somehow that switch is flipped. And it's flipped in a somewhat permanent way. I say somewhat permanent because I believe it can be switched back. Wow. I think you can change the microenvironment such that that switch is working properly. It knows when to produce energy when you need it, for that flight of stairs you need to go up. It knows when to rest and regenerate substrate when you need to repair. That's natural. We have to have substrate to repair after exercise. What's not natural is that it's in this state of growth semi-permanently, continuous states of growth. And that's when we get aberrant growth. We get tumors that grow out of control and that sort of thing. And then they spread to other places.
I imagine like sitting there eating a whole bunch of food that's sugary or whatever, and now you've got this excess energy, but you're just sitting there. Is there anything to that, like that simple idea there that we're not using the energy properly, that we're accumulating as we eat?
If you're going to sit around and eat donuts and chips all day, you're eating a bunch of empty calories. Those sort of food substances are going to break down and cause metabolic problems throughout. You know, I visualize it this way. I've got this huge poster of all the biochemical pathways on the wall, and it's very, very complex. It looks like the street map to London. That's the only way we can really kind of visualize and understand how electrons pass from point A to point B. But in reality, it's more like a cloud. These elements we call flux. These reactions are going on at different rates, at different parts of the body all the time. And so the idea is to try to tip your metabolic state into one that is favorable for energy production and not favorable for constant growth. So when we eat these junk foods, we are setting up a microenvironment that shifts those metabolic pathways down the wrong side. Every single biochemical decision has to be made at every single point. The cell is trying to think, now, do I divide and multiply like crazy? Do I make energy? Do I rest? These decisions are constantly being made. You're flooding the system with bad food, excess calories. The body's overburdened. It's got to do something with that. It's going to shunt much of that to fat production. Adipocytes are going to enlarge, and you're going to get big. What compounds the problem is that your respiratory apparatus is now compromised. You can't do the exercise. And so these things together are shunting biochemical pathways towards a state of constant growth, not the direction you want to go.
Yeah, because like when you're sitting there, you're not breathing like you would be if you're moving around, right? And so
Correct,
with a lack of oxygen for that respiration to occur, could it be that because I'm not breathing enough?
That is helpful to breathe properly, but it's important to realize that cancer cells do this constant growth, even in the presence of oxygen. Okay. So oxygen, although it's important, doesn't appear to be the key to driving this process. Now, absolutely, good deep breathing, relaxation techniques, things that calm the system down. These, again, influence that flux. And so what we want to do is practice things that improve flux towards a more natural state rather than a state of growth.
Now, we're hyper-focused on just one aspect of cancer, right? There's many more aspects of cancer.
Exactly.
And I guess the Warburg effect is essentially the same thing. It's just hyper-focused on one aspect of cancer.
Exactly.
So what other, hallmarks, like there has to be a vascular supply and
Correct,
there has to be other things going on. What are some of those other things?
Yeah, in fact, Otto Warburg was, very adamant that this was the key to cancer, and he was convinced that cancer was going to be cured in 4 years. He made this big announcement way back in the 50s, I believe it was, because it all came down to this mitochondrial failure. But the truth is that there are many factors that contribute to cancer growth, and there are mutations, harmful substances in our atmosphere and our foods and that sort of thing, smoking, unsafe sex. I mean, there are many things that can contribute to cancer.
And you say unsafe sex, you mean like
There's some
viruses?
sexually transmitted cancers, absolutely. Wow. Cervical cancer being the main one. There are many factors, not just this mitochondrial aberration that lead to the causation of cancer.
When we're looking at this mechanism of action here, this whole pathway or whatever, we're looking at the after effect here. It's not the genesis, it's not how it started, right?
It's often difficult to pinpoint how it absolutely starts, but it starts decades before it's detected.
Yeah.
I mean, many people go to the hospital, get a biopsy, come home, get a report, and think now I have cancer. When in fact, no, you've had cancer. You've had cancer for years. It's just now manifests itself as a palpable mass or something you can see on an X-ray picture. And so what has happened is that these people have set their system up for a state that cancer enjoys and thrives in. And so the whole point of our meeting here is is to use nutrition as one of the tools to get your body back in that state of flux that goes away from uncontrolled cell growth.
Yeah. And before we go too far in that direction, I just wanted to clarify what Warburg was looking at or observing was helping him understand what was going on with a cancerous cell, but it doesn't explain how that began.
Correct. Right. Yeah. He was looking at mitochondrial dissociation from oxidative phosphorylation process.
Yeah.
You know, Dr. Warburg discovered just one of the components in the oxidative phosphorylation pathway, but he was convinced that was the only one. And he also didn't have the benefit that we have now of the proton pumps and things that actually make the ATP, that generate the ATP in the process. So he was convinced that this is mitochondrial damage, plain and simple, and if we can figure out why these mitochondria are being damaged, we can cure cancer, and that's why he was so confident. Well, in the meantime, the world goes on to investigate other things. I mean, we look at viruses, we look at genetic mutations and such. And we come up with many different causative agents, you know, alkylating agents and carcinogens in the atmosphere and that sort of thing. And so it's now all come full circle. And again, everybody thinks that Warburg had the answer all along. Now he was right in a sense that cancer is most likely a metabolic disease. It's a metabolic failure. I think he didn't quite get the whole grasp because he had just limited information at the time.
Yeah. Oh, and he was just focused on that. And
right.
It's good to be focused on one thing and understand that we need to be focused on mechanisms, but we also need to consider the synergy of other things, you know, being involved. Food synergy, but we can go there in a minute. If all we're doing is describing what's occurring at this moment, we're still not clear on how it began. We don't know how to prevent it then, and we probably don't even necessarily know how to treat it, right? If we don't know how it began.
Well, there are all sorts of successful treatments for cancers, but I don't think any of them really cure the cancer without the patient's full participation. That's one of the major frustrations I've seen in my career is patients come in and say, fix me. And I'm a radiation oncologist. I use very powerful x-rays to obliterate tumors. And I can treat and effectively reduce a tumor most of the time if I can see it and target it. But I haven't cured the patient. The underlying problem's still there. And I believe it's a metabolic issue. The microenvironment reflects their macroenvironment. I mean, we live in a cesspool. We're exposed to all sorts of toxins on a daily basis, in the air, in the water, in the food. There's dioxins and heterocyclic amines and chemicals in our foods and additives and so forth. And so I guess the message is, if you want to reduce your chances of getting cancer, you need to reduce your exposure to these things. And you do that by eating a whole food plant-based diet. I mean, if you elect to eat meat, you're eating biohazardous materials in their most bioaccumulated form possible. And that adds up. And that, again, we're talking about that decision that each biochemical pathway makes. You're in the presence of these hazardous biochemicals. You're going to make the wrong decisions metabolically, and you're going to end up in that state. So to reduce your risk of cancer, I firmly believe, stay away from meats, stay away from dairy foods, oils, refined flours, anything in a box, bag, a package, a wrapper, chips, crackers, cookies, cakes, simple sugars, salt, excess salt, and just eat real food. I mean, that's truly what we're on this planet to do, is eat real food. Don't eat man's food, eat God's food. Eat the food that was provided for us.
The World Health Organization categorizes processed meats and even red meat as a class 1, class 2 carcinogen. What's going on there?
Yeah, well, so many people don't realize that hot dogs have the exact same carcinogens as that found in cigarettes. So if you're feeding your kid hot dogs, you might as well just give them a pack of cigarettes. It's the same carcinogen. And we all agree that, yeah, cigarettes cause cancer, finally. It took us forever to admit that. But the same thing's going on with the food. I saw a graph. They were looking at the use of cigarettes in this country over the decades. And of course it peaked around 1964-ish, somewhere in there. And the average American was smoking 4,000 cigarettes a year. The average American. That was the average, all the population. Yeah. And then, of course, that's when the Surgeon General came out with a report, cigarettes are bad, we got to get rid of cigarettes. And very slowly, very steadily, cigarette use has dropped in this country. And so many people in the whole food plant-based world feel that we're somewhere around 1957. That we're approaching that apex where the data just becomes so overwhelming that even the ketomaniacs have to agree. Yeah.
Dr. Kim Williams, I interviewed him last night, and he mentioned that there's a chance we might see a red, yellow, and green dot on food at some point.
Yeah, Dr. Greger used to do that on his site. Yeah, I always enjoyed those old videos, red light, yellow light, green light. Yeah.
The reason why I went to the meat, and I'm glad you mentioned smoking, these are things that we believe wholeheartedly cause cancer. They are the origin, the genesis of the cancer, we think. This is what started it. There's no glucose in cigarettes. Or maybe there is if you ate it. But when you're smoking it, I don't think there's any glucose in there. That's at the heart of what these people that are resurrecting the whole Warburg thing, they're saying glucose and glutamine. These are the culprits here. But we don't see those things in the red meat, processed meat, smoking. There's just so many things that could cause it, or at least contribute to it and exacerbate it. But could it be that if somebody's smoking or eating red meat, that it's because they're consuming glucose that the glucose became the problem, or is it that the red meat was the problem with the Warburg effect?
Okay, glucose is not a problem. We are glucose carbohydrate-seeking apes. That's what we are. That's our natural food, is to eat glucose in the form of plants. Now, that's a whole lot different than the form of a Snickers bar. A Snickers bar has no fiber in it. It's a totally unnatural product. You eat that Snicker bar, your blood sugar is going to skyrocket. It is, and within a matter of minutes. If you eat foods in their natural form, yes, you're taking in sugars through the fruits and vegetables, but because they are connected with fiber, they're in fibrous form, it takes a while to digest those. So you're not getting these huge glucose spikes. And so, whole food plant-based diet, for instance, is an excellent way to control diabetes because you're getting this slow rise in your sugar. You're not getting these huge spikes. You're not having to raise your insulin up to push it down constantly. For the same reason, it's an anti-inflammatory diet. To me, it dovetails perfectly with a cancer-fighting diet. Now, where the glutamine comes in and the glucose is that lately, through studies, looking at fermentation, there's this popular idea that cancer cells feed off of glucose and glutamine. They're just fermenting cells. That's what they're going to feed off of, glucose and glutamine. And of the two, glutamine's probably even more important because glutamine brings nitrogen to the whole system. Nitrogen is an important component to many biological structures that the cells got to make to reproduce. So glutamine is probably the big key player. Now, glutamine's in everything, and it's what we call anapleuritic. In other words, it shows up. It's the party crasher. So you block one way, it's going to show up in several other pathways to the party. So it's virtually impossible to starve yourself of glutamine or to get rid of it. There are medications that bind it up. Unfortunately, they're very toxic because cancer cells aren't the only cells that use it. Things that are rapidly reproducing, blood cells, GI tract cells, they're going to need that glutamine. So if you bind up the glutamine in the body's not going to be very happy. You're going to be pretty sick. So a lot of these glutamine binding agents are pretty toxic. They're just very tough to tolerate. So the idea has been purported on the internet is to try to block cancer or starve cancer basically by avoiding glucose and getting rid of glutamine. Well, we are, as I discussed, we can't get rid of glutamine, so we got to figure that out in separate step.
You can't get rid of glucose either, right?
It's hard to get rid of glucose too, but that's where the ketogenic folks come in because they're all, no carbs, let's push the glucose levels down.
Don't they still go through gluconeogenesis though at some point?
Yeah. I mean, if you're eating a lot of protein, but people who are on ketogenic diets really shouldn't be eating a lot of protein. That's not what a ketogenic diet is. 70–80% fat. That's what a true ketogenic diet is. It's very difficult to do.
So they don't go through gluconeogenesis?
If they're really doing ketose properly, they shouldn't, because they're not taking in a lot of protein. But the truth is, most keto followers do eat a lot of protein. So they like steaks and burgers and things, and they think by just avoiding the bun that they're doing this huge favor, when in fact they're not. But that's another discussion. So anyway, the idea is let's get rid of glucose. Let's do that with a ketogenic diet. So you get a ketogenic diet, glucose levels plummet. You get into a state of ketosis. Cancer cells can't use ketones, so that's a plus. But what do you do about that darn glutamine? I mean, it shows up everywhere. And so there are ways to try to bind it up, like I say, but these drugs are very, very toxic. There's this idea now of what's called a press pulse therapy. The press is a constant stress, and then you add a pulse stress on top of it, and populations die. And it's based off of animal behavioral studies and such. I mean, it's kind of a disparate science where this whole concept came from. But if you place a cell under constant stress and then hit it with a even higher stress, the idea is that cell will die off. And so, all right, we're in ketosis, we got our glucose level down. We can't really get this glutamine down because we don't have effective drugs to do that. So we look at other therapies. And one therapy looked at was, I think, hyperbaric oxygen, which is a very useful tool for divers who surface too fast and they get an air embolism, and their oxygen bubbles out of their system too fast if they rise too fast. So we put patients in a tank under pressurized oxygen, simulates putting them back down underwater, several atmospheres, and then you bring them up slowly and that oxygen will stay in solution and avoid the problem. Well, it turns out hyperbaric oxygen is useful for other things too. It's useful primarily for chronic wounds that are hypoxic and that sort of thing. It's also very expensive. It's also not very readily available, and it's certainly not approved for cancer treatments. So good luck getting it paid for. So there are folks out there who purport, this press pulse therapy, and they even go so far to say, if your doctor doesn't do this, they're participating in your murder. They're literally killing you. And I think that's a bit unfair, because this is a very nascent idea, but we're left with no real option to follow. So a lot of patients who are watching some of these videos on the press pulse therapy are left empty-handed. They just don't have a treatment regimen to follow. And I've tried to kind of see who's performing these therapies, and it's very difficult to kind of nail down who exactly is providing these therapies. That has been a big point of contention lately.
And is there any evidence that these are even as effective as the alternative?
There's absolutely no data, no long-term data on them, absolutely not. And to say that, if you're not participating in it, that you don't know what you're doing, or you're participating in the murder of your patient, is quite unfair.
So do I need to be worried about glucose? As long as I'm eating whole plant foods?
Right, yeah. So,
but the occasional cookie?
Right. So
maybe stressing a little too much, not sleeping enough?
Exactly. It's turning out that the stress is probably the biggest culprit.
The stress about the cookie?
Perhaps so. Now, the stress, just overall general life stressors also play an important role in that metabolic flux. And which pathways things go down. So if you're in a state of constant stress, you're in a bad job, a bad marriage, a bad whatever, your life has no purpose, these things drive up blood pressure and adrenaline and what have you. They contribute to that metabolic flux and help drive the metabolism into that constant state of growth. Wow. It turns out stress is one of the important things. But do you have to worry about glucose? You need glucose. That's our fuel. We live off of glucose. We are apes, plain and simple. Yeah. We eat what apes eat, and they are carbohydrate-seeking animals. And they eat fruits, vegetables, nuts, seeds, occasional insects. They might eat a piece of meat, but that is extremely rare and not on their normal diet. Most apes eat plants, hundreds of different kinds of plants in their environment.
It's interesting because Dr. Seyfried, he's the one who's really seeming to push this right now, this whole idea of the Warburg effect being the thing, and glucose being the culprit, and going on a ketogenic diet being the solution. That was a big part of me, like, reaching out to you and anxiously wanting to do this.
Sure.
But at the same time, there's also theories about protein being the culprit and other macros, you know, like the fat, of course, being a culprit. But he's hyper-focused on the carbohydrates, essentially. But at the same time, he says that chimpanzees don't get cancer. And like you said, they eat over 100 different plant varieties. So they're getting glucose in their diet.
Sure, yeah, they eat fruits, vegetables, plants, seeds, nuts, yeah.
Our closest relatives, the chimpanzee, they never documented a case of breast cancer in a female chimpanzee, yet breast cancer in the United States has now replaced heart disease as the #1 killer of women.
He does make a very dangerous tenet by implying, anyway, that ketosis is a cancer preventative mode.
Yeah, I mean, how many chimpanzees are on a ketogenic diet?
It would be nearly impossible. I mean, they just don't have access to that sort of fat content in their diet. And so, exactly.
Yeah. I mean, or bonobo, like.
Right, so the ketosis, many people think that that's the healthy way to go, and unfortunately I think these people are setting themselves up for major problems down the road with the cholesterol and the fat that they're consuming. I think he even goes so far as to suggest you get a little monitor and that you constantly be in ketosis. And by his own admission, that's a state of stress. That's the press stress, that's the constant stress. And so to put your body in a constant state of stress all your life, again, you're manipulating that metabolic flux into a path for growth.
One time when I was thinking about all this, listening to different people talk about it, it was almost as if like I had this idea where whatever diet you're on, if you get cancer, if you just do the exact opposite, then it seems like that would be a metabolic switch that might help things. I mean, is that a weird
Well, I've
theory?
never thought about going from a whole food plant-based diet
to a carnivore diet.
Carnivore diet.
I mean, but if you had cancer,
if you developed cancer as a whole food plant-based practitioner, but I still couldn't recommend that.
Yeah,
I mean, because when you're eating meat, you're eating highly inflammatory substances. You're eating very highly condensed biohazardous agents. Plus, you're avoiding all these wonderful agents that fight cancer. You know, the sulforaphane and all the ingredients that the antioxidants and vitamins and nutrients that you find in fruits and vegetables. So to me, it just doesn't make sense. Carnivores, ketosis people, they're going to have a very acidic environment. They're going to be very, in general, pretty hypoxic. They're not going to have the same aerobic capacity. And those are conditions ripe for cancer. You know, cancer loves that acidic, hypoxic soup. And the idea is to change that to an alkaline, highly oxygenated environment.
I wonder like how many vegans that you've seen, because there are vegans that do get cancer. And there's even children that get cancer. I mean, like,
exactly.
They haven't even been around long enough to be stressed out as long as I have. I don't even know how any of this can explain that, you know, like a child getting cancer. You know, because it's easy to beat yourself up if you think, oh man, I got cancer and I'm my own worst enemy. When a child gets it, it's like, maybe it's just beyond our control. Like,
right. There are things that we'll never be able to explain, and childhood cancer is one of those. It's a tragic development. But yeah, that just goes to show you there's a whole lot more to it than just nutrition. I'm not saying that a whole food plant-based diet is going to cure cancer or prevent it 100% of the time, but it certainly lowers your risk significantly. And so if you look at epidemiologic studies, those that follow vegetarian diet, vegan diet, whole food diet, their risk for cancer is low, lower, lowest. Ketone diet, carnivore diet, standard American diet, higher, higher, higher. You know, the idea is to try to beat the odds, put them in your favor.
But what kind of evidence or science out there, meta-analysis, or is there anything out there scientifically speaking that would evidence what you just delineated there?
Well, sure, yeah, there are many studies. There's the EPIC study, the Harvard study. If you look at large populations, meta-analyses over many decades, there's the nurses study, all of these show incremental risk rise with meat, with dairy, with eggs. That's basically what this conference is all about. And we go over that ad nauseum. That is epidemiologic. And so those people who love meat say, well, that's not causative. We don't have a randomized study. Well, when is that going to happen,
or a study where it's looking at meat without all the other stuff in it.
It's impossible to factor out all those risk factors.
Unless somebody's just living that way,
Right.
But then you don't have a large population. Then.
Well, there's the Adventists in California. There's a large population. You study the blue zones, and you kind of drill down on what they eat, and you realize, they're eating a healthy diet, mostly plant-based. A little bit of oil over here, a little bit of grains over here, a little bit of meat, what have you. But pretty much it's the same. Whole food, plant-based diet with little variations.
Yeah. What do you think about like a vegan that gets colon cancer?
Blows my mind. That's a head scratcher, don't know.
Yeah.
Like I said, it's not a panacea. It's not going to cure everything. But if you're truly a plant eater and you get colon cancer, then you got into something somewhere, some sort of substance somewhere. Probably would never sort out where it came from.
Everything we were talking about in respect to this being a metabolic disease and that whole process there that you were talking about, the Warburg thing. Does that apply to all these different types of cancers, or are there some that are completely different?
I think some cancers certainly respond better to lifestyle changes than others. Breast cancer, for instance, and prostate cancer. These are ones that we've actually seen, genetic changes for the good in patients who go from standard American diet to whole food plant-based diet. There are tumors that are tough. There's the glioblastomas, there are the pancreas tumors. These are tough tumors that don't respond immediately to sudden and drastic lifestyle changes.
I think Dr. Seyfried mentioned glioblastoma, and that being the one that was the one he was focused on the most.
I think so. I mean, most of his data appears to be on brain tumor, which is kind of a different beast. Brain tumors typically don't spread places. They're typically a local problem that just insidious, continuous growth takes the patient down.
And maybe there's something to that, the whole ketogenic thing, because if it works for epileptics, then maybe it makes sense that you see something there with brain cancer.
Brain cancer is a tough one to crack. But to me, making your whole body acidic, hypoxic, does not seem conducive to any sort of health, really. But
now, I've heard recently that breast cancer has surpassed heart disease for the leading cause of death of women. I don't know if that's true. I didn't fact check it.
I haven't seen that yet, but it was on the trend to do so. Well, these cancers are inflammatory diseases, just like heart disease, just like diabetes, arthritis, Alzheimer's disease. All of these things have very similar metabolic links. They're very similar. So if you're fighting one, you're really fighting all of them. Over the years, looking back at my patient population, it's uncanny how many come in with the triad: high blood pressure, diabetes, arthritis, and then they get cancer. I don't know exact number. Easily 80% of my patients have diabetes, heart disease, and high blood pressure.
Suddenly I had this epiphany earlier on about how diabetes relates to this topic.
Well, diabetes is an inflammatory disease, and it is hallmarked by these spikes in blood sugar. It's been shown that a whole food plant-based diet can reverse type 2 diabetes, particularly if you jump on it soon enough. It's an underlying inflammatory process. I mean, if we put a diabetic on a whole food plant-based diet, we're not going to see these spikes in blood sugar. They're eating fruits and vegetables, nuts and seeds and grains. They're going to have that nice slow rise in blood sugar and controlled blood sugar. So to me, it's one and the same. And the same is true with heart disease. It's trying to avoid those big sugar spikes, the subsequent insulin spikes to suppress that sugar spike. And that's what appears to be driving these inflammatory processes.
Studies dating back nearly a century noted a striking finding. If you take young, healthy people and split them up into two groups, half on a fat-rich diet and the other half on a carb-rich diet, within just 2 days, this is what happens. The glucose intolerance skyrockets in the fatty diet group. In response to the same sugar water challenge, the group that had been shoveling in fat ended up with twice the blood sugar. As the amount of fat in the diet goes up, so does one's blood sugar spikes. It would take scientists nearly 7 decades to unravel this mystery, but it would end up holding the key to our current understanding of the cause of type 2 diabetes. When athletes carb load before a race, they're trying to build up the fuel supply within their muscles. They break down the starch into glucose in our digestive tract. It circulates as blood glucose, blood sugar, and is taken up by our muscles to be stored and burned for energy. Blood sugar, though, is like a vampire. It needs an invitation to come into our cells, and that invitation is insulin. Here's a muscle cell. Here's some blood sugar outside, waiting patiently to come in. Insulin is the key that unlocks the door to let sugar in our blood enter the muscle cell. When insulin attaches to the insulin receptor, it activates an enzyme, which activates another enzyme, which activates 2 more enzymes, which finally activates glucose transport, which acts as a gateway for glucose to enter the cell. So insulin is the key that unlocks the door into our muscle cells. What if there's enough insulin, but the insulin doesn't work? The key is there, but something's gummed up the lock. This is called insulin resistance. Our muscle cells become resistant to the effect of insulin. What's gumming up the door locks in our muscle cells, preventing insulin from letting sugar in? Fat. What's called intramyocellular lipid, fat inside our muscle cell. Fat in the bloodstream can build up inside the muscle cell, creating toxic fatty breakdown products and free radicals that can block the signaling pathway process. So no matter how much insulin we have out in our blood, it's not able to open the glucose gates, and blood sugar levels build up in the blood. This mechanism by which fat, specifically saturated fat, induces insulin resistance wasn't known until fancy MRI techniques were developed to see what was happening inside people's muscles as fat was infused into their bloodstream. And that's how they found out that elevation of fat levels in the blood causes insulin resistance by inhibition of glucose transport into the muscles. And this can happen within just 3 hours. One hit of fat can start causing insulin resistance, inhibiting glucose uptake after just 160 minutes. Same thing happens in adolescents. You infuse fat into their bloodstream, it builds up in their muscles and decreases their insulin sensitivity, showing that increased fat in the blood can be an important contributor of insulin resistance. And then you can do the opposite experiment, lower the fat in people's blood, and the insulin resistance comes right down. Clear the fat out of the blood, and you can clear the sugar out of the blood. So that explains this finding. On a high-fat diet, the ketogenic diet, insulin doesn't work as well. Our bodies are insulin resistant. But as the amount of fat in our diet gets lower and lower, insulin works better and better. This is a clear demonstration that the sugar tolerance of even healthy individuals can be impaired by administering a low-carb, high-fat diet. But we can decrease insulin resistance, the cause of prediabetes, the cause of type 2 diabetes, by decreasing saturated fat intake.
Well, what's interesting is when you go on a ketogenic diet, like you said, you eat a lot of fat.
Yeah.
And fat could very well be the underlying culprit. What's causing the diabetes?
Oh, absolutely. I mean, that's been shown. Dr. Bernard has shown that.
This has implications for cancer as well. Obesity leads to insulin resistance, and our blood sugars start to go up. So our pancreas starts pumping out more insulin to try to force more sugar into our muscles, and eventually the fat spills over into the pancreas as well, killing off the insulin-producing cells, and we've got diabetes, in which case we may have to start injecting insulin at high levels to overcome the insulin resistance, and these high insulin levels promote cancer.
Many of these harmful agents, the heterocyclic-amines and acrylamides, they go to fat. They get absorbed in fat. That's really toxic people have these big layers of fat. They're storing these toxins. It's a kind of a defense mechanism. So if you're eating a lot of animal fat, that's unfortunately where all these biohazardous materials are bioaccumulating, is in the fat. So you're even compounding it.
I mean, I don't know how long anybody's ever done the ketogenic diet.
Yeah, I don't know anybody that's done it forever.
Now, have you had patients that took your advice maybe with this whole food plant-based diet and seen success with that?
Unfortunately, it's few and far between.
What is the patients that actually do it?
That actually
Okay.
do it. Yeah, I mean, everybody that comes through our clinic has to hear my spiel, and you could see many of them. The eyes are rolling and say, "Yeah, give me the paper, let me get out of here."
Yeah.
But every once in a while, we have somebody who's eager for the information, and I give them the plantrition information, and I have some guidelines that I printed up, and some resources and some recipes and things that we've collected. I'd say a handful have really taken to it, and they just do better. I mean, they tolerate treatment better. Their counts don't drop as low if they're getting chemo. They don't tend to get as sick. Their energy levels don't drop. That's what's so impressive, is that, you know, cancer therapy, radiation, chemo just really saps your energy. Mm-hmm. And so folks that tend to stay on a whole food plant-based diet keep their energy levels up.
I met somebody recently who had colon cancer, had the bulk removed and some lymph nodes removed, and instead of getting chemo, they just went on a whole food plant-based diet. They did 90 days raw, and then they went on to predominantly eat a whole food plant-based diet. And 7 years later, here they are still today, and they're doing great. So that was pretty exciting to hear that. Do you have some story in particular like that you could share?
Well, it's important to realize that, you know, that's a great story, but there's also the opposite. So we can't pin everything on if we eat 100% plant-based diet, we won't get cancer.
Yeah.
I can't stress that enough. You know, I have not been doing it long enough in the clinic really to see reversals of disease and that sort of thing. I can tell you that one of the big issues is that people lose weight. When they eat a whole food plant-based diet, it kind of forces you to your natural body weight. So my colleagues are just freaking out. Oh my gosh, because they want you to maintain your weight while you're under
Even if you're
chemotherapy.
overweight?
Even if you're overweight. If you're 350 pounds, they don't want you losing weight. I'm like, yeah, you're going to lose weight. So I even have referring physicians upset with me. You got to get these people food. They're losing too much weight, and so they look great. You know, their color's better, energy's better, and yet my colleagues still don't see it. They still don't.
But you do have some that have been able to take on this lifestyle and
sustain it.
Yeah.
And that's what's really cool about it, is that, you know, if you talk to people who did Atkins or did South Beach or did this diet or that diet, how many of them are on it years later? Zero. I mean, nobody's on it 3 months later, much less a year later. But story after story, once you go whole food plant-based and you realize how good it makes you feel, it's a breeze to stay on. It really is. In fact, you don't want to get off of it. It's the only one I know that works that way.
I know people who've been vegan from birth.
Envious.
Yeah. But the ones that do the whole food plant-based, oh my gosh, they're on zero medications. I mean, even Mark Huberman.
And myself, you know, I was a typical, horrible, sad eater, standard American diet. You know, overweight, cholesterol out the roof, blood pressure, ringing in the ears, arthritis, blood sugar was rising. And now I started running. I hated running. I always hated running.
Yeah.
And now I'm going to run another half marathon in a couple of weeks. So,
Cool.
Yeah.
Awesome. Clearly, glucose is not the culprit when it's coming from whole plant foods. And that was my main thing I wanted to get out there, because it's easy to get carried away with things like Dr. Seyfried saying what he's saying, and or what about other cancers instead of the one like the lifestyle, because he's hyper focused on the glioblastoma or whatever. Well, what about these lifestyle related ones that are the leading causes of death, right? I mean, we're talking lung cancer is leading, right? But breast cancer, prostate.
Right. And he makes this comment that, you know, every mitochondria that they studied, he and his colleagues, was damaged in their cancer population. But again, I get the feeling he's only looking at astrocytoma or glioblastoma, brain tumors, which really are kind of an odd actor. They're really a different beast compared to these epithelial tumors that we see, lung cancer, colon cancer.
And they're not, and that's not a lifestyle related one when a child gets glioblastoma. I mean, that's not a lifestyle related cancer.
Again, you know, I don't have all the answers.
No, I know, yeah. It doesn't seem like it would be.
Well, yeah, but there is evidence that the lifestyle of the parent reflects the offspring, yeah.
Wow, yeah. I keep hearing that.
But, you know, you certainly don't want to place blame on parents. I mean, there's a lot to learn. We have a lot still to learn.
You shared with me in an email some cancer facts that was kind of interesting. You want to hit on some of those real quick?
Yeah, one of the interesting ones, I think it was Dr. Seyfried's research, is that if you take a cancer cell and you take that nucleus out, you have a healthy cell over here and you switch it, take its nucleus out and put the cancerous nucleus in that healthy cell, you think, oh, we're going to see cancer. It doesn't turn into cancer. That doesn't happen. Yeah. But if you take the cytoplasm out of this cell that's cancerous,
where the mitochondria is.
Yeah. And switch it with the cytoplasm in the healthy cell, all of a sudden this one turns cancerous. You know, so for years, I mean, when I went through school and high school and college, med school, you know, there's this theory, there's this gene theory that cancer starts with a mutation and then another mutation and so forth. This accumulation of mutations kind of drives the bus. The cell first starts dividing out of control, and then it eventually learns how to invade tissue surrounding it, and then it eventually learns how to break off and survive in the blood system for a while, and then set up camp and invade somewhere else and make a new tumor. And these are all accumulations of genetic mutations that are driving this bus. And it's turning out that that's not at all the case. It appears that these genetic mutations that we see are really a downstream event. It's happening because the cancer is happening. It's not driving the bus. And the theory is, and it seems to hold a lot of truth, is that the mitochondrial DNA appears to be the key player here. Because when the cell is trying to become cancerous and shift metabolic activities into that state of constant growth, it's sending off signals to the nucleus to turn on and off certain genes to keep that process going so that the cancer survives. So the key appears to be in the mitochondria. It's pretty interesting and pretty exciting, because if we can manipulate that process in the mitochondria and shut that down, perhaps we can flip the switch back into a more normal metabolic state.
And in lifestyle behaviors could be one thing that might create a microenvironment, like you say, for the mitochondria
to behave.
Right, yeah. Was there any other facts?
Well, for folks that are really interested in this, there's an excellent summary of it. Nick Lane's book, Transformer, Chapter 5. If you want kind of a concise explanation, I know I didn't do it justice. I'm not a biochemist. Nick Lane talks about it in his book, Transformer, and very, very fascinating. Oh, another little interesting tidbit in my research is that the mitochondria that you possess and I possess came from our mothers. Oh, yeah. That's pretty interesting, isn't it? Yeah. That at the time of conception, the mitochondria in the sperm, they don't get in. They get excluded. And so all the mitochondria that you carry with you are of maternal origin.
And they call it the mother's curse?
The mother's curse, because if there is a mitochondrial disease, it's carried by the maternal line.
Wow. Wow. Pick your women wisely. I'm just kidding. What is the biggest risk factor for cancer, you think?
Yeah, so the biggest risk factor is age, hands down. As we get older, we get more cancers. So a 50-year-old is going to get 90% more cancers than a 20-year-old. And that risk doubles every decade after 50. Wow. Doubles and doubles and doubles. And you think, well, that's got to be due to genetic mutation, right? I mean, we're just accumulating this genetic instability. And it turns out that no, that's not the case, because spontaneous mutation does not occur fast enough to explain that doubling time. So there's something else going on. And that's where the mitochondria driving the bus comes into play, because these mitochondria are not really causing mutations per se, but they are turning certain genes on and off on demand, by direction from the mitochondria.
Now, when you said spontaneous, you made me think about people who spontaneously heal.
Spontaneously heal, yeah. So it's interesting, if you look at those that spontaneously heal, they've made drastic lifestyle changes across the board. They cleaned up their diet, they threw the cigarettes away, they pretty much threw the old lifestyle out the window. They oftentimes quit their job, did something totally different, something that they always dreamed of doing. They really found themselves more in harmony with what they feel is their purpose here on this planet, hands down, universally. I can't say it's always been a whole food plant-based diet that they've landed on. Most of the time it is, but it is a drastic change.
Yeah, Zach Bush, he was on Rich Roll's podcast, really fascinating talk, and he mentioned the spontaneous healing, trying to help his patients, like in an individualized way, hone in on how they can achieve that. You know, a doctor might look at somebody and try to treat them like they're treating every patient the same, you know, boom, boom, boom,
Right,
boom.
right.
But he's trying to take a more individualized approach.
Sure.
And then I can't help but think about like lifestyle medicine and the 6 pillars there of health, but also like Dr. Kim Williams was mentioning, I think it was the American Heart Association has like 8 pillars, and then True North has like 3, but they're all kind of saying the same thing, you know, eat right, sleep, stress management, don't do drugs. Do you have a list?
Absolutely. You know, eat properly, get enough sleep. There's mindfulness, sense of purpose in life, getting enough exercise, avoiding harmful substances, alcohol, cigarettes, things that we know are bad for us.
Yeah. And that might explain why some vegans might get cancer. Maybe they're drinking alcohol, or maybe they're not getting enough sleep.
Yeah, again, you know, I'd hate for anyone to pin it on one thing. There's no one thing. Oh gosh, if I hadn't had that beer, or oh gosh, if I just had my echinacea tea. Or, I mean, there's no one thing, right, that it leads to it. It's more of a holistic mindset. You know, eating this way has really kind of opened my eyes. It's really changed the way I see the world and my place in the world. You know, eating a whole food plant-based diet, I firmly believe is the true human diet. And when you eat this way, you feel wholly human.
One thing that's come to fruition for me is, in addition to these pillars of health, there really, it seems to be, for me personally, an underlying core thing there, like the hub of it all. Like if all these pillars of health were like spokes on a wheel, and the hub is love.
Is love, yeah, absolutely. And it's really self-love. Love yourself, and you do that by taking care of yourself.
Yeah, and that's something I'm trying to put out there more and more in these videos, that core thing here, because I do feel like it affects everything else. If you don't love yourself, why are you going to get enough sleep? Why are you not going to do drugs? Why are you going to eat right?
Right, yeah.
Why you're not going to emotionally eat? You're going to try to be more disciplined. This might be a good point to segue into, like, what are the biggest lifestyle lessons you've learned and can share?
If you're facing an inflammatory disease, whether it's a chronic infection, a chronic wound, or acute trauma, or chronic heart disease or lung disease, the basis of healing is through good nutrition, good sound nutrition. And that, to me, means whole food plant-based nutrition. And there are many ways to go about healing yourself, like some of the mindfulness practices we talked about, and there's Western medicine, and there's Chinese medicine, Ayurvedic medicine, there's herbalists. It doesn't matter, or maybe you want to try a combination of these. The foundation is going to be a whole food, plant-based diet, sound nutrition. Because if you don't have a sound base, you won't be able to heal, at least not wholly.
What are some of your biggest frustrations?
Yeah, some of my biggest frustrations are these folks that feel somehow that they're immune to all this, that their biochemistry is so much different than the rest of humanity's, that they can eat these harmful foods with impunity and no consequence. And you know, give you an example. I love to dance. My wife and I love to dance. We dance all the time. We go to weddings. We love being invited to weddings because they usually play our music. We went to this particular wedding, danced from the first dance to the last. It was all our music. It was great. A friend of ours, stopped us in between sets to say, God, you guys just don't stop. It's unbelievable. How do you have so much energy? And of course, I share my story. How, 7 years ago, I was really large and couldn't breathe, and no way I could have done this. And he goes, isn't that interesting? Some diets work for some people, whereas other diets work for other people. And then he goes on to tell me about how his keto diet has been so favorable for him. It's got his numbers down and all this. And I'm thinking, well, I don't see you out on the dance floor, buddy.
Nice.
And so that's probably one of the biggest frustrations, is this sense of immunity that, yeah, I can do what I want.
It seems like the younger they are, the more invincible they are.
Right. Yeah.
And the more ironic it is, the older I get and the more energized I am.
Sure.
What are some kind of resources that maybe people could check out to learn more about this kind of stuff and at least think about what we're talking about here?
I think anybody that's interested in this interview really should go out and see some of the videos on Dr. Greger's site. There's two in particular. One is on meat and its association with diabetes. And the second one is the 10 hallmarks of cancer. And many people would say, well, you know, I don't have diabetes. Why should I go? I'm concerned about cancer. Why should I go look at this video? And that video actually goes on to demonstrate how all of these diseases, cancer, diabetes, heart disease, are really related in the fact that they're inflammatory diseases. And so by fighting one, you're really fighting all of them. And how we respond to stress is totally individualized. And, you know, my family, I was destined to die at an early age with heart disease. Others may generate a cancer or diabetes or a combination of these things. So we all handle stress in a different way. But we can all fight these diseases in the same way through a whole food plant-based diet. The second video discusses the 10 hallmarks of cancer, which is a very famous paper, came out in the year 2000. It initially had 5 or 6 hallmarks and then upgraded to 10 a few years later. And it's basically things like sustained cell proliferation signals and avoiding apoptosis and things that cancer cells key on to survive. And so, predictably, the pharmaceutical companies have aimed at all 10 of these hallmarks to try to find various agents to attack cancer from these certain areas. These are things like angiogenesis and systemic inflammation. Every cancer has 1 or 2 or 3 of these different mechanisms going for them in order to survive. Well, Dr. Greger makes a very interesting point in that broccoli, kale, cauliflower, things like this hit not 1 or 2 or 3, but oftentimes all of these hallmarks simultaneously.
I think that's what he calls food synergy.
Food synergy? Well, yeah. I mean, they're hitting many hallmark pathways simultaneously. Yeah. And they don't have all these side effects like these drugs do, or the cost. So I tell everybody with cancer, you should be eating broccoli every meal. Eat broccoli. You don't have to have a lot of it, 1 or 2 florets, but eat it. The rawer, the better. Yeah.
Sprinkle a little mustard powder on there.
Sure.
If it's
no,
cooked.
Eat broccoli, not powder.
No, I'm saying just to get the myrosinase and the sulforaphane.
Oh, yeah. I chew it up. You know, there's that theory where you chop it up and you let it sit there for a while.
5 minutes.
I just chew it. And while I'm preparing it, I just pop 1 or 2 of the little florets in my mouth, and I'm just chewing away while I'm preparing.
And the reason why we're saying that is because if you cook it, it destroys one of the compounds that helps create the sulforaphane.
Right, I understand it's kind of like a psyllium stick. You crack it, and the chemicals mix, and then you get the glow.
Yeah, okay, there you go.
That's kind of the idea. And so if you just throw it in the water, you kill the enzymes that make that happen. So you want to start that process before you cook it, and then you don't want to cook it to death.
Or you could add a little raw to your cooked.
Exactly, you could do that, or do like I do, just munch on a few little florets while you're preparing it.
There you go. Is there any exciting research on the horizon that you're looking forward to following up on?
Yeah, I'm interested in this mitochondrial role. I think it's very exciting that it's kind of been pinned down to the mitochondria themselves. I think the injury, if there is one, is in the mitochondria. It's not necessarily a devastating injury that's going to kill the cell, but there's something going on there that's driving the cell nucleus to direct cancer growth. And I think that's a very exciting area to be looking into.
So where are we going to see you again? You're getting ready to retire?
I am. I'm retiring. Going to take some time away from the cancer world, basically spend this year figuring out what I'm going to do. But I'll be back in some form or another.
Yeah, hopefully you'll be back at the NHA conference.
Absolutely. This is a great conference. Fantastic.
Yeah, you think you'll be here next year?
Absolutely. Going to be here. Yeah.
Awesome. Well, it's so great seeing you again, and thanks so much for your time.
My pleasure. Awesome. Thank you.